Under the immense span of the divine circle, a gigantic red star among the generally radiant and easily discernible heavenly bodies attests to its predominance along the horizon, arranged a long ways beyond our full comprehension. This monstrous, infinite substance has the capacity of delivering an energy greatness that could equal the combined brilliance of an incalculable cluster of stars. This cosmic giant, conceivably almost there of a prophetically catastrophic event, may soon release an eruption of such size that it would be able to dominate 1 billion suns. The genuine question is, are we prepared for the consequences such an event could bring? This monster red star, frequently alluded to as Goliath, lives somewhat near Earth and has emerged as a subject of critical interest and discussion within both established researchers and the wider public. Recently, this star went through a significant change, provoking growing concerns among scientists and energizing intense conversations regarding its future direction. The most disturbing possibility is that this adjustment could signal the beginning stages of a cosmic explosion, an unstable heavenly phenomenon marking the last phase in a star's life cycle. If Alpha Orionis, the scientific name for this star, were to deplete its atomic fuel, it could fall under its own gravitational force, setting off a devastating blast. The very thought of such an event sparks anxiety, not just among researchers but also for those of us inhabiting Earth, as the potential results could be unprecedented. Alpha Orionis, easily recognized by its deep ruby tint, holds the title of being the largest and most brilliant star in the Orion constellation. With the aid of cutting-edge tools like NASA's Hubble Space Telescope, cosmologists have closely observed its behavior, especially in 2019, when it experienced an emotional loss of mass, a phenomenon that is considered rare for stars of this type, raising alarms across mainstream researchers. While our Sun regularly goes through coronal mass ejections, the unusual event observed in Alpha Orionis has sparked a reassessment of what happens during the last stages of a massive star's life. Researchers are currently divided over the exact distance of Alpha Orionis from Earth. Estimates vary, with some placing it as far as 1,200 light-years away, while others suggest it may be as close as 724 light-years. The difficulty in accurately determining the position of stars like Alpha Orionis lies in the enormous distances involved and the elusive nature of red giants. Despite uncertainties regarding its exact location, Alpha Orionis continues to enrapture observers as one of the most dramatic objects in the night sky, shining several times brighter than our Sun. However, this brilliant shine comes at a significant cost. Alpha Orionis is burning its atomic fuel at an accelerated pace, which speeds up its journey toward the inevitable end of its life cycle. Once it depletes its fuel supply, the star will likely collapse, potentially forming either a neutron star or, in a more catastrophic scenario, a black hole, depending on how the explosion unfolds. This leads to an urgent question. Could Alpha Orionis pose a threat to Earth? Should a cosmic explosion occur within a few light-years of our planet, the implications would be devastating. A cosmic explosion can release an incredible amount of energy, possibly surpassing entire galaxies, which presents the possibility of widespread consequences, even if Alpha Orionis lies at a considerable distance from Earth. The most recent cosmic explosion event recorded in our galaxy occurred in the year 1604, and since then, humanity has not witnessed a similar event on a local scale. However, a significant cosmic explosion erupted in 1987 in the Large Magellanic Cloud, located a staggering 169,000 light-years away. Although this explosion had notable ramifications for its immediate environment, it posed no direct danger to Earth. Nonetheless, these rare occurrences serve as stark reminders of the colossal scale of cosmic explosions and the risks they may present. A cosmic explosion, especially one happening near Earth, could create what has been termed a hazard zone around the heavenly blast. The dangers to life on Earth, however, should be viewed in the broader context of extreme events. While supernovae are relatively common, gamma-ray bursts, GRBs, represent an even more powerful threat. These explosions are capable of destroying entire planetary biospheres and flooding them with lethal radiation. For example, GRBs can obliterate a planet's ozone layer, leaving it exposed to harmful ultraviolet radiation from its sun, impacts that could endure long after the burst has subsided. The impending threat of gamma-ray bursts has become a focal point of ongoing research, revealing new insights into the potential risks associated with heavenly explosions that culminate in such dramatic and disastrous events. When massive stars explode as supernovae, their brilliance can outshine entire galaxies. This power raises a critical question. What might happen if Alpha Orionis were to undergo a similar transformation? If it were to explode as a cosmic explosion, it could become the second most brilliant object in the sky, second only to the sun in terms of visibility. Even at a significant distance, the energy released in such a blast might be so intense that it could be visible even during daylight hours. This blinding spectacle would cast shadows in the middle of the afternoon, offering a striking but unsettling experience for those witnessing it. While the visible light emitted by a cosmic explosion would undoubtedly be a breathtaking sight, the real danger lies in the high-energy radiation accompanying such an explosion. This radiation, often in the form of X-rays and gamma rays, would have far-reaching consequences. One of the most pressing concerns is its potential to strip Earth's protective ozone layer. Without the ozone layer, life on Earth would be exposed to harmful levels of ultraviolet radiation, potentially leading to extinction events. The risks presented by a cosmic explosion don't stop following the blast. The remnants of the explosion, including shockwaves traveling at nearly the speed of light, would continue to pose dangers as they spread throughout the solar system. These shockwaves could further damage the ozone layer, exposing Earth to an even greater risk of harmful radiation, which would only elevate the dangers over time. Moreover, the long-term effects of the cosmic explosion's energy release could linger for an extended period, leaving lasting damage to the planet. Interestingly, some studies suggest that Earth may have already been impacted by the fallout from a cosmic explosion in the past. Elevated levels of iron-60, a radioactive isotope produced in cosmic explosion blasts, have been detected in remote ocean sediments and lunar soil, indicating that Earth has likely experienced the aftermath of such an event within its geological history, potentially within the last few million years. Currently, there are no known cosmic explosion candidates near Earth that present an immediate threat. However, ongoing research continues to uncover new potential dangers, especially from cosmic explosions capable of generating long-range, deadly radiation. These explosions occur when a star nearing the end of its life is surrounded by a massive ring of material, and the shockwaves from the explosion interact with this material, producing intense X-ray radiation that can travel vast distances. The process of supernovae providing material for the birth of new stars highlights the cyclical nature of the universe, where the death of one massive star lays the groundwork for the formation of another. This perpetual cycle of birth, death, and rebirth is a fundamental aspect of the universe's structure. As stars like Alpha Orionis approach their final stages, the remnants of their explosive deaths contribute to the cosmic material that fuels the formation of future generations of stars. This ongoing process of star formation and destruction not only shapes the structure of galaxies, but also influences the overall evolution of the universe. The elements that are created during a supernova, such as heavier metals and elements essential for life, are dispersed into space, enriching the interstellar medium and making it possible for new stars and planetary systems to form. Without these cosmic explosions, the universe would lack many of the elements necessary for the development of planets and life as we know it. As scientists continue to explore the remnants of supernovae and their role in stellar evolution, they are uncovering even more insights into the processes that govern the universe's expansion and the formation of complex structures. For example, studying the supernova remnants allows astronomers to refine their models of stellar evolution, particularly for massive stars nearing the end of their life cycle. The data gathered from these observations may help us predict future stellar events and better understand the fate of stars like Alpha Orionis. In the grander scheme of the universe, The study of cosmic explosions and their aftermath not only deepens our understanding of the life cycles of stars, but also offers crucial information about the dynamics of galaxies, the expansion of the universe, and the potential risks that may arise from nearby stellar events. As our knowledge of these processes grows, we gain a clearer picture of the forces that shape our cosmos and the potential threats that could arise from the death of distant stars. Ultimately, the study of stars like Alpha Orionis and the broader phenomenon of cosmic explosions serves as a reminder of the vast and often unpredictable nature of the universe. While such events may seem distant and abstract, they remind us of the interconnectedness of all things in the cosmos. The life and death of stars, the formation of new worlds, and the potential for cosmic disasters are all part of the dynamic and ever-changing story of the universe. As we continue to explore these phenomena, we gain not only a deeper understanding of our place in the cosmos, but also a greater appreciation for the fragility of life on Earth and the immense forces that shape the universe around us. In this context, the ongoing study of cosmic explosions, star formation, and the fate of stars like Alpha Orionis provides not only scientific insight, but also philosophical reflection on the nature of existence and the future of our planet in the grand scale of the universe. The events that occur in the far reaches of space may seem remote, but they have the potential to impact our understanding of life, the cosmos, and our place within it. As we continue to advance in our exploration of space, we are likely to encounter even more profound revelations about the universe's evolution and the forces that govern its development. Making of people in the future of stars drives the advancement of the world and adds to the ever-changing design of the universe. As stargazers proceed to examine cosmic explosion remnants, they're finding that new stars can rise up out of the gas and residue in these districts, even years after the underlying blast. Cosmic explosion leftovers, with their complex creations, are additionally one of the universe's essential wellsprings of weighty components. Like iron, gold, silver, and uranium are framed in the limit states of a cosmic explosion blast, and they are dispersed into the interstellar medium, advancing the matter that will eventually structure new stars, planets, and indeed, even life itself. Without these weighty components, the nearby planet group, and, to be sure, our presence wouldn't be imaginable. Supernovae, hence, are not only disastrous occasions. They likewise assume an imperative part in the making of the very components that make up the stars and planets we notice today. Moreover, the investigation of supernovae has extended how we might interpret the universe's extension. By noticing the brilliance of type Ia supernovae, brought about by the blast of a white smaller person in a parallel framework, cosmologists can measure grandiose distances with remarkable exactness. These standard candles have upset our capacity to plan the universe, giving essential data about dim energy and the speeding up development of room. In spite of the critical advances in our capacity to quantify enormous distances, the potential perils presented by cosmic explosions can't be neglected. Albeit the probability of the close by cosmic explosion influencing Earth stays low, the long-term results of such a blast could be significant. As referenced prior, supernovae emanate serious radiation that could disturb the sun-based framework's climate. This radiation could connect with Earth's climate, draining the ozone layer and uncovering life to destructive ultraviolet radiation from the sun. Without the ozone layer, endurance on Earth could become progressively troublesome, if indeed feasible. Moreover, the shock waves from a close-by cosmic explosion could disturb the construction of the nearby planet group. These waves would pack the interstellar medium, possibly setting off the development of new stars or adjusting the circles of items within the sun-based framework. In the most dire outcome imaginable, a close-by cosmic explosion could upset the sensitive equilibrium of the planetary group, prompting horrendous changes in planetary circles and perhaps even compromising Earth's presence. The study of supernovae and their remnants also brings up captivating issues about the fate of the universe. As stars bite the dust and cosmic explosions happen, their leftovers can eventually form black holes or neutron stars, probably the most puzzling and outrageous items in the universe. Black holes, specifically, are districts of space where gravity is extraordinary to such an extent that not even light can escape. These items are accepted to be the last stage for the most monstrous stars, and their development is quite possibly of the most interesting peculiarity in current astronomy. Regardless of their damaging nature, supernovae are vital to the ongoing advancement of the universe. The materials they discharge into space act as the building blocks for the development of new stars and planetary frameworks. As new ages of stars are conceived, the pattern of heavenly life and demise keeps driving the advancement of worlds and adding to the universe's steadily expanding nature. In the end, while the expected danger of a cosmic explosion blast remains a far-off worry for Earth, the investigation of these occasions is fundamental for propelling our comprehension of the universe. Supernovae not only give important bits of knowledge into the life cycles of stars, but they also offer pivotal data about the synthetic creation of the universe and the manners by which worlds advance over time. As we continue to investigate the tremendous ranges of space, how we might interpret these emotional astronomical events will develop, offering a clearer and more complete perspective on the universe's past, present, and future. As we move forward in our investigation of the universe, plainly contemplating these huge, enormous peculiarities like supernovae will continue to uncover new layers of understanding about the universe and its many-sided components. Each move toward this research carries us nearer to getting a handle on the genuine extent of how stars live, die, and contribute to the dynamic, ever-evolving universe around us. Supernovae and their aftermaths, for example, neutron stars and black holes, address probably the most captivating and secretive parts of astronomy. These peculiarities raise significant inquiries about the ultimate destiny of stars and their role in the larger infinite structure. The cycles that lead to a cosmic explosion blast involve incredibly complex atomic material science, but the subsequent effects stretch across tremendous distances, affecting the development of whole systems, affecting the introduction of new stars, and enhancing the universe with fundamental weighty components. Getting at how these situations develop and the conditions that trigger such hazardous occasions assist researchers with sorting out the riddle of heavenly development. In addition to the basic job they play in star arrangement and the production of components, supernovae act as a critical device for measuring infinite distances. By dissecting the light from these emotional heavenly blasts, stargazers can make more precise guides of our universe, following the extension of room and the conveyance of worlds across huge distances. These estimations are fundamental in deciding the age scale and construction of the universe, and they have prompted earth-shattering disclosures concerning a puzzling power known as dull energy, which seems, by all accounts, to be speeding up the extension of the universe. This exact capacity to gauge distances utilizing cosmic explosions has had wave impacts all through astronomy. By giving more detailed and solid strategies for measuring distances across the universe, we have acquired a more profound comprehension of the rate at which the universe is growing and how galaxies are advancing. The presence of dull energy, first construed through observations of far-off supernovae, has reshaped our comprehension of the universe's future. It isn't just to suggest that the universe is growing, but doing so at an accelerating rate. Yet, regardless of the staggering information acquired from these cosmic explosion studies, the possible dangers from a close-by cosmic explosion blast remain a central worry. While such an occasion is far-fetched in the prompt future, the chance, however remote, demands our attention. The damaging impacts that accompany supernovae, especially the radiation and shock waves they produce, can have huge effects on neighboring planets. If Earth were to fall within the scope of such an event, the outcomes would likely be disastrous. From the obliteration of the ozone layer to the interruption of the planetary group's sensitive equilibrium. Understanding these risks forces researchers to deeply consider how life on Earth could be impacted by grandiose occasions. If the ozone layer were to be drained by radiation from a cosmic explosion, Earth's atmosphere would no longer protect life from harmful solar radiation. The planet could be assaulted by deadly ultraviolet beams,